In 2013, Explorer 1 accomplished a surprising achievement by becoming the first human-made object to enter interstellar space. This extraordinary accomplishment happened 36 years after its takeoff from Earth. The space apparatus presently resides 14.5 billion miles from Earth, requiring about 2 days for the transmission and collection of messages. NASA engineers never hypothesized that Explorer 1 would continue its space investigation for almost 50 years. In 2023, Explorer 1 identified 500 unidentified objects moving through space, igniting immense conversation. Notably popular podcaster Joe Rogan joined the discussion to shed light on the disruptive implications of this uncommon discovery. These strange objects could have been created by extraterrestrial creatures or simply been a malfunction of the space apparatus. The mystery has fascinated researchers for quite some time. However, recent extraordinary encounters in deep space have sent shockwaves through the scientific community, possibly revealing insights into the age-old question of the existence of extraterrestrials. Joe Rogan, a prominent reporter and podcaster, known for his distinct interest in examining extraterrestrials and the possibility of advanced civilizations, has previously hosted guests like David Grush and Avi Loeb to explore the potential for life beyond Earth. The notable Explorer 1 mission was conceived in the 1970s when NASA researchers had the opportunity to truly grasp the vastness of our immense universe. It all began with an unlikely alignment of Jupiter, Saturn, Uranus, and Neptune, the 4 largest planets in our solar system. A young PhD student named Gary Flandreau discovered a remarkable celestial phenomenon that would guide space exploration in the late 1970s and early 1980s. The 4 planets aligned in a stunning configuration resembling pearls on a great necklace with Earth nestled among them. This discovery sent waves of excitement through NASA as it presented a unique opportunity to streamline the trajectory of a spacecraft by cleverly utilizing the gravitational pull of each planet during flybys. Flandreau estimated that these gravity assists from the giant planets could shorten the flight time from Earth to Neptune from 30 years to just 12 years. However, this celestial alignment occurred only once every 176 years, prompting NASA to embark on an ambitious mission to capitalize on this once-in-a-lifetime opportunity. Explorer 1 and Explorer 2 were twin spacecraft launched in 1977 to investigate the mysteries of the solar system. Launched 15 days apart, they became integral components of NASA's Explorer space program, a testament to humanity's insatiable curiosity and quest for knowledge. For nearly 50 years, Explorer 1 has been transmitting valuable data back to Earth through NASA's Deep Space Network, bridging the gap between our earthly existence and the secrets that lie beyond. Currently, Explorer 1 is 24 billion kilometers away from Earth, standing as the farthest man-made object from our planet. The spacecraft was meticulously designed and built by NASA's Jet Propulsion Laboratory and began its historic journey from Launch Complex 41 at Cape Canaveral Air Force Station, propelled by a Titan II launch vehicle. One key feature of Explorer 1's launch was the presence of dual redundant computer systems. Both Explorer 1 and its twin Explorer 2 were equipped with 2 sets of Command Computer Subsystems, CCS, Flight Data Subsystems, FDS, and Attitude and Articulation Control Subsystems, ACS. This redundancy ensured smooth transitions between systems and the ability to activate dormant computers when necessary, thereby extending their lifespan. The computer systems on board the spacecraft were arranged as a distributed system, with 3 redundant sets of computers, ensuring that if one system failed, the others could seamlessly take over, preventing critical failures. Power management is a crucial aspect of maintaining the operational integrity of Explorer 1, especially as the spacecraft's distance from the Sun, where it can harness solar power, presents significant challenges. Engineers had to devise innovative ways of monitoring and optimizing power usage, including implementing specific power shutdowns for non-essential systems. In summary, Explorer 1 and Explorer 2 have been instrumental in uncovering the secrets of the nearby solar system and interstellar space, providing pivotal insights into the vastness of space and the mysteries that lie beyond our understanding. Explorer 1, a space probe that has defied all odds, has been transmitting vital information nearly 50 years after its launch. Initially expected to last only 5 years, Explorer 1 has been equipped with a wide array of scientific instruments and subsystems. These instruments were strategically placed on the spacecraft's body, which contains an astonishing 65,000 individual parts. One of the enduring instruments on both Explorer 1 and Explorer 2 is the Low-Energy Charged Particle Detector. This instrument boasts 3 sets of particle sensors that measure the number of low-energy particles striking it, as well as their speed. It continuously monitors high-energy radiation and particles coming from the sun, planets, and interstellar space. A companion instrument, the Cosmic Ray Detector, actively searches for high-energy particles from both the sun and other celestial sources. The plasma wave subsystem, which includes 2 extended radio antennas arranged at right angles to each other, serves as a critical tool for measuring the electric field components of potential waves encountered at the outer planets. However, its role has evolved as the explorers ventured into interstellar space. Over the years, engineers have made remarkable technical advancements and improvements in power management techniques, including more efficient power distribution, enhanced battery charging methods, and advancements in power regulation and control. Explorer 1 continues to transmit essential data, demonstrating the dedication and creativity of the engineers and scientists who have worked tirelessly to keep it operational. The Explorer missions, initially designed to study the magnetic fields of outer planets, have undergone significant changes as they journey into interstellar space. The magnetometer, originally focused on the magnetic fields of outer planets, now plays a crucial role in studying the transition region between interplanetary and interstellar media. This instrument examines the magnetic properties of the transition zone, the boundary where the sun's magnetic influence gives way to the magnetic field of interstellar space. The Plasma Science instrument, which analyzes the low-energy particles within plasma, is currently operational only on Explorer 2. This instrument embodies NASA's ongoing scientific investigation. The agency has intentionally deactivated radiators on both spacecraft after 21 years of operation, and non-essential instruments have been permanently turned off. The power source for each spacecraft is 3 radioisotope thermoelectric generators, RTGs, which use the heat generated by the radioactive decay of plutonium-238 to produce power. As plutonium-238 continues to decay, it will eventually be unable to provide sufficient power, leading to the suspension of all instruments around 2025. To extend the operational lifespan of both spacecraft until 2027, the Explorer team is employing careful power management strategies. Each spacecraft is equipped with transmitters to maintain communication with Earth. The primary transmitter emits about 20 watts of power. However, the strength of the signal from Explorer 1 reaching Earth is 20 million times weaker than that of a modern wristwatch battery. Explorer 1's journey through space has not only expanded our understanding of the solar system, but also provided crucial insights into the nature of the heliosphere, the bubble of charged particles surrounding the Sun. As Explorer 1 moved further from the Sun, it began to encounter different environmental conditions than those experienced by previous spacecraft. Perhaps one of its most significant contributions has been its role in mapping the structure of the heliosphere and its boundary, known as the heliopause. This boundary marks the transition between the solar wind and the interstellar medium, where the Sun's influence wanes and material from other stars begins to dominate. By sending back data from its plasma wave instrument, Explorer 1 has helped scientists better understand the behavior of plasma in this transitional zone. This information is critical for understanding how cosmic rays from outside the solar system interact with the heliosphere and how these interactions affect space weather. Such insights are vital not only for space science, but also for protecting future spacecraft and astronauts from harmful space radiation. Another key aspect of Explorer 1's mission is its contribution to the study of magnetic fields. As Explorer 1 crossed the boundary into interstellar space, it provided the first direct measurements of the magnetic field beyond the Sun's influence. These measurements have been instrumental in enhancing our understanding of the magnetic environment of the interstellar medium. The data collected helps scientists model the magnetic interactions between different regions of space and understand how these interactions influence large-scale phenomena. Explorer 1's longevity and continued data transmission have also contributed to a better understanding of the properties of interstellar dust. The spacecraft's dust detector has been crucial in measuring the density and speed of interstellar dust particles. These measurements provide valuable information on the composition and distribution of dust in our galaxy, which in turn influences theories about star formation and the evolution of the interstellar medium. The spacecraft's ongoing mission has also shed light on the advancement of technology used in space exploration. The engineering achievements of Explorer 1's mission have set a benchmark for future deep space missions. The innovative design and resilience of Explorer 1 systems have influenced the development of subsequent spacecraft, illustrating how engineering solutions can extend the life and effectiveness of space missions far beyond initial expectations. Moreover, in addition to its scientific achievements, Explorer 1 carries a symbolic message for any potential extraterrestrial civilizations. The Golden Record, containing sounds and images designed to represent the diversity of life and culture on Earth, serves as a universal greeting and a testament to humanity's desire to connect and share its presence with the cosmos. This message, along with the spacecraft's data, represents a monumental step in humanity's quest to explore the universe and engage with intelligent life beyond our world. Overall, the Explorer missions have made significant strides in their exploration of interstellar space and the mysteries surrounding the discovery of 500 unidentified objects. When Explorer 1 first identified these mysterious objects, the data sent back to Earth was distorted, resembling a garbled message from the universe. NASA's Jet Propulsion Laboratory, JPL, was baffled by the confusion and found that the Attitude Control and Guidance System, ACS, had switched to using a malfunctioning onboard computer that had been dormant for years. This caused distorted telemetry data. NASA engineers quickly fixed the issue by reconfiguring the ACS to transmit data through the correct computer. Uncorrupted data from Explorer 1 is now streaming back, but the question remains: what caused the ACS to use the faulty computer? NASA researchers have yet to provide a definitive answer, but have proposed a theory suggesting that the ACS received a corrupted command from another onboard computer. Susan Dodd, project manager for the Explorer Interstellar mission, revealed that a comprehensive memory readout of the ACS would be conducted, followed by an extensive assessment of its activities to determine the root cause of the telemetry issue. Several factors could contribute to the anomaly, including the environmental conditions of space, cosmic radiation temperature changes, and exposure to micrometeoroids such as dust particles and debris from asteroids and comets. As Explorer 1 ventures deeper into interstellar space, its plasma wave instruments have consistently detected the effects of dust particles due to their high-speed impacts. When a dust particle collides with the spacecraft, it disintegrates and ionizes, creating a growing plasma cloud that triggers a voltage pulse in the spacecraft's plasma wave antenna. While these findings provide crucial information about the interstellar environment, they also highlight the challenges of long-term space exploration. The interplay of cosmic radiation temperature fluctuations and micrometeoroid collisions can impact the functionality of spacecraft systems over time. Although NASA has proposed conventional hypotheses to explain the telemetry anomalies observed in Explorer 1, one possibility that has captured the imagination of the public and belongs to the realm of science fiction is the involvement of extraterrestrial beings. While this theory is highly speculative and not widely accepted within the scientific community, it raises fascinating questions about the potential for intelligent life beyond Earth. The idea of intelligent extraterrestrial life has intrigued scientists and space enthusiasts alike for decades. Joe Rogan, a prominent podcaster and media figure, has explored this topic through conversations with scientists, UFO enthusiasts, and former government officials. Among them is David Grush, a former Air Force intelligence officer and representative of the National Awareness Office for Unidentified Aerial Phenomena, UAP. These discussions have fueled public interest in the anomalies observed in Explorer 1's data. Rogan and others suggest that the vastness of the universe, containing billions of galaxies, stars, and potentially even more planets, makes the existence of intelligent civilizations elsewhere plausible. If such civilizations were to encounter Explorer 1, they might notice the spacecraft as it traverses the universe and decide to investigate it, perhaps out of curiosity. This hypothetical scenario raises the possibility that the telemetry anomalies could be their way of sending an intentional message, a form of interstellar greeting. Adding to this speculation is the presence of the golden record on board Explorer 1. This interstellar time capsule, designed to communicate the diversity of life and culture on Earth, contains sounds, images, and scientific information. If extraterrestrial beings were to access the golden record, they might interpret it as an invitation to engage with humanity. The record includes greetings in 55 languages, music from various cultures, and images of Earth's natural wonders, human achievements, and daily life. Such a discovery could provide extraterrestrial civilizations with insights into Earth's culture's scientific knowledge and technological advancements. Meanwhile, NASA scientists remain focused on unraveling the scientific mysteries presented by Explorer 1. Beyond the golden record and speculative theories, the spacecraft's contributions to understanding the heliosphere, interstellar medium, and cosmic phenomena remain at the forefront of space exploration. The data collected by Explorer 1 continues to refine our understanding of how interstellar space interacts with our solar system, offering critical insights for future missions. One particularly groundbreaking contribution of Explorer 1 has been its role in mapping the structure and dynamics of the heliopause, the boundary where the sun's solar wind meets the interstellar medium. This region acts as a protective bubble, shielding our solar system from high-energy cosmic rays. By studying the heliopause, scientists can better understand how this boundary influences space, weather, cosmic ray penetration, and the conditions that future spacecraft and astronauts may face. The plasma wave and magnetometer instruments on board Explorer 1 have provided invaluable data on the composition and behavior of particles in the transition zone between interplanetary and interstellar space. These findings are helping researchers model the interactions between the solar wind and the interstellar medium, offering new perspectives on the processes that shape the evolution of our galaxy. Despite its remarkable achievements, Explorer 1's mission is nearing its end. As its power source, the RTGs, continues to decay, the spacecraft's ability to operate its instruments will gradually diminish. NASA engineers have already implemented power-saving measures, shutting down non-essential systems to prolong the spacecraft's operational lifespan. It is estimated that by 2027, Explorer 1 will cease transmitting data altogether, marking the end of a historic journey that has redefined humanity's understanding of the cosmos. In the meantime, the scientific community remains captivated by Explorer 1's discoveries and the enduring questions it raises. From the mysterious 500 unidentified objects it detected to its exploration of the heliopause, the spacecraft's legacy will undoubtedly influence future space missions. Whether through advancements in spacecraft design, deeper investigations into the interstellar medium, or continued exploration of the possibility of extraterrestrial life, Explorer 1 has paved the way for a new era of discovery. As humanity looks to the future, the lessons learned from Explorer 1 and its twin Explorer 2 will serve as a foundation for ambitious endeavors in space exploration. The curiosity and ingenuity that drove the creation of these spacecraft are emblematic of humanity's enduring quest to understand its place in the universe. And while the mysteries of the cosmos remain vast and largely unexplored, Explorer 1 has shown that even the most daring missions can yield profound insights into the nature of existence itself.